Completing the square is an operation that you will use in algebra again and again. Completing the square means to create a perfect square trinomial from a two-term polynomial involving only one second degree and one first degree term. It is used on quadratic expressions and expressions that can be treated as quadratic forms of some other expressions. Now what does all that mean? Well, let's take a perfect square trinomial, I don't know, x squared plus 10x plus 25. Right? That's a perfect square trinomial. And if we want to factor this trinomial, we could factor it as x plus 5 times x plus 5, or simply x plus 5 squared. And this is a unique kind of trinomial because it can be rewritten as a binomial squared, not even just as the product of two binomials, but as the square of one binomial. You'll find that that property is really helpful. So the goal of completing the square is to find trinomials and even to create trinomials that look like this. Let's look at a few more. X squared plus 6x plus 9 can be rewritten as x plus 3 squared. Alright, so that's one. We've got x squared minus, let's say, 12x plus 36. That can be rewritten as x minus 6 squared. So that's a perfect square trinomial. We've got, let's try x squared. Actually, let's try 4x squared plus 28x plus 49. We can actually factor this one as 2x plus 7 squared. So this is a perfect square trinomial. But this one's kind of special because it's got a 4x there at the beginning instead of just an x squared, and this is a 2x instead of just a plain x. So this one has an extra coefficient in front of the lead term. So recognizing that this kind of trinomial exists, but temporarily ignoring it, what do the other three have in common? Well, they all have positive constant terms. So we've got positive 9, positive 25, and positive 36. They all have a leading coefficient of 1. So we got 1x squared, 1x squared, 1x squared. But then they don't all have the same sign for their middle term. We've got positive 6, positive 10, and then negative 12. But what can we notice about the relationship between the middle term and the last term? Well, the middle term in this case is 6. What's half of 6? 3. What's 3 squared? 9. How about this middle term is 10. What's half of 10? 5. What's 5 squared? 25. What's half of 12? What's half of negative 12? Negative 6. What's negative 6 squared? Positive 36. They all have that relationship. We can find more perfect square trinomials like this. Let's take x squared plus, give me some even number, 8x. Alright, what's half of 8? 4. What's 4 squared? 16, so plus 16. And we can rewrite that as x plus 4 squared. Okay, now where does this relationship come from? Well, notice that half of 6, I said, is 3, and 3 squared is 9, and we've got a 3 right here. Half of 10 is 5, and 5 squared is 25. We've got a 5 right here. Half of negative 12 is negative 6. We've got a negative 6 right here. So there's a very close connection between the binomial that we're going to square to get this trinomial and the trinomial itself. Let's explore that connection a little bit more deeply. Alright, let's take a binomial. Any binomial will do as long as it's in the form x plus or minus k. And let's take a binomial like that and square it. So let's start with x plus 3 squared. Alright, so x plus 3, and we'll square it. So if we square it, we could just say we multiply it by itself, right? And let's multiply x plus 3 times x plus 3. We should get x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. Alright, let's try x minus 4. Let's multiply x minus 4 by itself. That'll give me x squared minus 4x minus 4x plus 16, or x squared minus 8x plus 16. Let's try x minus 7 squared. X minus 7 times x minus 7 should be x squared minus 7x minus 7x plus 49. Alright, notice that these all have positive last coefficients because we're either taking two positive numbers and multiplying them by each other, or we're taking two negative numbers and multiplying them by each other to get a positive number, because this positive number is just a last term squared. Alright, and this can be rewritten as x squared minus 14x plus 49. So what can we see about the relationship between the binomial that we squared and the trinomial that we ended up with? Well, we see that this last term of the binomial, this k, ends up being multiplied by the x, and then the other k is multiplied by the other x, so we get 3x plus 3x, and they add together to give us a coefficient of 2k, twice this constant right here. So we've got a negative 4 multiplies by this x, and another negative 4 multiplies by this x. We get negative 4x minus 4x gives us negative 8x, and negative 8 is twice negative 4. Same thing with the negative 7's here. They add together. Negative 14 is twice negative 7. And then we see that this k term, is multiplied by itself at the end to give us k squared. So 3 squared is 9, and we get 9. We've got negative 4 squared is 16. We've got 16 there. Negative 7 squared is 49. Same thing. Let's be more general now, and let's actually use a k. So x plus, I'm going to say x plus k squared, or x plus k times x plus k. First we multiply the x's together. That's going to give us x squared. Then let's multiply this x by the k there, and we get plus kx. Multiply this k by this x, and we get plus kx. And then multiply these two k's together to get plus k squared. Alright, and now we can just simplify to get x squared plus 2kx, and I'm going to put the 2k in parentheses there, plus k squared. So we can see that in general, no matter what this is, and I didn't even specify whether it's negative or positive, right? So even if it's x minus k, that's just saying plus negative, some negative number. Our perfect square trinomial is going to be x squared plus 2kx plus k squared. So our middle coefficient is going to be twice a certain number, the number that's right here, and then our last coefficient is going to be the square of that number. So why is this helpful? Well, let's play a little game. Let's play Guess the Trinomial. Alright, so I'm thinking of a trinomial that starts with x squared plus 4x. Alright, and this is a perfect square trinomial. You have to guess what this last term is. Have you guessed it yet? Well, if 4x is 2kx, then 4 is 2k, so k is 2. And then the last term is k squared, so that's 4. So that should be my perfect square trinomial, and it can be rewritten as x plus 2 squared. Let's play another round. X squared minus 16x. And then what's my third term? Well, if you take half of this, you'll get negative 8. And if you square it, you'll get positive 64. So plus 64 is my last term. Alright, and then that can be rewritten as x minus 8 squared. Let's try just two more, since that's what it looks like we've got the space for. Let's try x minus, I'm going to get big now, x minus 30, sorry, x squared minus 30x plus, what's my last term? Well, you take half of 30 is 15, or negative 15. Square it and you get positive 225. And then I can rewrite this as x minus 15 squared. And one more, I'll do an easy one this time. X squared plus 2x. What's my last term? Hopefully you should know it by now. 1. So I've got x plus 1 squared. So completing the square is just playing this game where you try to guess what the third term of the trinomial is. And all you have to do is take the first term, cut it in half, and then square it. So the KP uses pretty general terms here. It says that if you have x squared plus ax, what you're going to add is the square of a over 2, and then you can rewrite the whole thing as x plus a over 2 squared. Or if you have x squared minus ax, you add the square of a over 2, and you have a trinomial that can be rewritten as x minus a over 2 squared. So that's exactly the same thing. You just take half of the middle term, and then you square it to get the third term. Alright, let's try, see if you can guess this trinomial. X squared plus 5x plus, what's the third term? Well, you're going to have to take this 5, cut it in half, and you get 5 over 2. So our binomial is going to be x plus 5 over 2. And when we square it, we'll get x squared plus 5x plus, and the last term is going to be the square of this term right here, so that's going to be 25 over 4. So sometimes you're going to have a little bit of a harder time with this. Let's try an even harder one. Alright, x squared plus 3 over 5x, 3/5 of x, plus, what's my third term going to be if this is a perfect square trinomial? Well, what's half of 3 over 5? Half of 3 over 5 would be 3 over 10, so our binomial would be rewritten as, or would be x plus 3 over 10 squared, and then this 3 over 10 squared would give us my last term, which is 9 over 100. So this is my perfect square trinomial that can be rewritten this way. Now one thing I want to clarify. Am I saying that x squared plus 3/5 of x can be rewritten as x plus 3/10 squared? No. That's important. I'm not saying that this can be rewritten as this. I'm saying that if we have a perfect square trinomial that starts with this, we can guess the third term. The third term would be this, and then this whole thing, not this thing, but this whole thing, including the last term, can be rewritten this way. So that's why our KP tells us that when we take a binomial and turn it into a trinomial, the nature and numerical value of the polynomial changes. It's saying that if we took this binomial right here and turned it into this, we just changed it. We did something different to it. It's not the same thing it was before. So the new polynomial is not equivalent to the original one. However, completing the square is a valuable process that we can perform as long as we are able to offset this effect, usually in an equation where we can add a over 2 squared to the other side as well. So in order to get from here to here, what did we do? We added 9 over 100. Well, if this is one side of an equation, we can go ahead and add 9 over 100, and then just add 9 over 100 to the other side of the equation too, and then we can go ahead and rewrite this part as this. So that's why completing the square can be helpful, and you'll see more on this in my next video.